right, ladies and gentlemen, so now we're taking a look at function number 5 for the 1.1 notes. It says f of x equals the absolute value of x. I know it's absolute value because that's what those bars are representing, which means any number we plug in, we're looking at what is the distance of that number from 0. So we will only get positive values back out for our y values here because distance is always a positive number. You can't go back in time, right? Or have a negative distance. I'm going to use the same x values I've been using this entire time. So negative 2, if I plug that in for x, I have the absolute value of negative 2. Well, negative 2 has a distance of what from 0? 2. Negative 1, when I plug that in, has a distance of 1. 0 has no distance at all from 0 because it is 0. 1 is 1, and 2 has a distance of 2. So plotting these points here, we begin to get dots that look very similar to our quadratic function. But this is absolute value, and we know it's absolute value because when we connect these dots, we connect them with two linear lines that connect at the point 0, 0, and it looks like a V shape. So I always remember what the absolute value functions look like because they always give me the V shape, which is a part of the name. Absolute value. All right, last parent function we're going to talk about in this lesson is f of x equals square root of x, and this is the square root function. You could maybe call it the radical function as well, but square root is usually a little bit easier to remember. Now, this is the only one I don't use negative 2 and negative 1 on because you cannot take the square root of a negative number and have it be a real number. And the values I actually plug in for x, again, you can pick any numbers here as long as they're 0 or positive. But I'm going to pick numbers that are easy to square root because I have to think about graphing this. So I know 1 is a nice number to square root, 4 is good to square root, and so is 9. Because when I plug 0 in, the square root of 0 is 0. When I plug 1 in, the square root of 1 is 1. If I plug 4 in, the square root of 4 is 2. When I plug 9 in, the square root of 9 is 3. And 9, 3 doesn't quite fit on my graph, so I'm not going to graph it, but I have 3 points here. Now, the square root functions, I always know what they are because they have a starting point. Because we can't square root negative numbers and get a real number back out, so we have this starting point of 0, 0, and then it points in the direction of all the positive x values that we can plug in. The very last thing we're going to talk about in 1.1 is called constant differences. And there's really two things we're going to talk about with constant differences, and we'll eventually build upon this concept. But we're going to be looking at a first difference and a second difference. And remember, the word difference means we're going to be subtracting. Okay, so we're going to do a lot of subtraction here. In this bullet point here, it says, in a constant difference, we subtract successive terms. And so the way that that's interpreted is I'm going to subtract from the end of the graph to the beginning. So you might want to make a note of that. From the end to the beginning. And I'll show you exactly what that means in the example problem below if you're still a little confused on what that is talking about. Two things to highlight here. First difference is, if when we do the subtraction the first time around, the numbers are all equal, then we can say a linear function is going to best represent this table of information. If it's not the same the first time around when we do our subtraction, and we have to subtract a second time to get it to be the same, then we're going to say that it's a quadratic function. Okay, so the two things I've highlighted in this bullet point that you're going to want to make note of, first difference is equal, then linear. Second difference is equal, then quadratic. And we're going to go through what that means below. All right, so example 1, we're going to use constant differences. looking at part A. Now the piece that we're subtracting here is the y variable, so it's going to be the height in this case. And so I had mentioned above that when you subtract, you go from the end to the beginning. So what that means for us is I'm going to take 198 and subtract from it 163. So the math I'm doing in a calculator, maybe off to the side, is 198 minus 163. So 198 minus 163. I'll zoom in a little bit so you can see that better. So notice I'm starting at the end of the graph and I'm subtracting it by the number that came before it. And when you subtract those two values, you get positive 35. So I'm going to write down a plus sign to remind myself that this is a positive number. You might be like, oh, that looks like I'm adding 35. Well, technically you are. To get from 163 to 198, you're adding 35. 163 minus 128 is positive 35. Doing that process again, 128 minus 93 is positive 35. And 93 minus 58 is positive 35. So notice that when we did this subtraction from the end of the table all the way to the beginning, we got this same constant difference of positive 35. So our first difference is constant, meaning it's the same number. So if we were to come up with a function to represent this table, it would be linear. And we know it's going to be linear because when we did this subtraction, we got a constant first difference. I want you to take a moment and repeat this process with part B. Then press play to see the answer. All right, so hopefully you've given part B a try on your own. We're going to take 0 minus 99, which is negative 99. 99 minus 154, which is negative 55. 154 minus 165 is negative 11. And 165 minus 132 is a positive 33. They're not the same the first time through, which means we're going to go through this process again. And you might be wondering, okay, Mrs. Walker, I got here, but what do you mean do the process again? That doesn't make sense. What I mean is now we're going to take these numbers that I have written in pink, and we're going to subtract those starting from the end to the beginning. And this is why it's so important to make sure that you're keeping track of the sign of these numbers if it's positive or negative. Because now we're going to take negative 99 minus negative 55. So negative 99 minus negative 55. So we're still subtracting them, so make sure you add those signs in there. And that's going to give you negative 44. Then we're going to take negative 55 minus negative 11, and that gives us negative 44. And then negative 11 minus a positive 33 is negative 44. So notice the first time we did the differences, they weren't the same, but the second time, they are. So second differences are constant. Which means this table of values represents a quadratic function. Meaning if we were to come up with a function to represent this table of values, it would look like a quadratic function. All right, that concludes 1.1. You are now good to go to move on to the 1.1 worksheet.